Hello and welcome to the chemistry basic videos. I am Dr. Shams. Today we are going to discuss about chemical equilibrium and not the full topic, only 5 points. Rate of a reaction, law of mass action, reversible reaction, equilibrium and equilibrium constant. Let us start with what is rate of a reaction. Well, let us consider a chemical reaction A giving B, where A is the reactant, B is the product. A is being converted into product every time. We want to know what is the rate of conversion. So it is very easy. The rate of a chemical reaction is defined as change in concentration of A per unit time. Change in concentration of A per unit time, or rate of formation of the product. Very simple. So we can say rate of this reaction is equal to change, which we write by D, and A in this bracket, this represents the concentration. No other bracket represents the concentration. This A per unit time divided by time. Another way is D, concentration of the product, and time, both way. You can define what is rate of the reaction. Negative sign here means only that concentration of the reactant goes on decreasing. That's all. So again I repeat, what is the rate of a reaction? It is change in concentration of the reactant in unit time, or rate of formation of the product. Negative sign means that the concentration of the reactant goes on decreasing. The rate of the reaction depends upon concentration. It also depends upon temperature, and it also depends upon pressure if the reactants are gaseous. Yes, and very important thing, it also depends upon the catalyst. Catalyst affects the rate of the reaction. So this is, we have defined what is rate of the reaction. Law of mass action. Very simple. Law of mass action states that the rate of the reaction is directly proportional to the concentration of the reactant A. You have to write A in this bracket only. You cannot have any other bracket. R is directly proportional to the concentration of A. So R will be equal to a rate constant K into concentration of A. R is rate of the reaction, K is rate constant. It is also called as velocity constant. This is law of mass action. Again I repeat, law of mass action states that the rate of any chemical reaction is directly proportional to the concentration of the reactants. Third is reversible reaction. Now, let us consider reaction A gives B. A is reactant, B is product. There are many reactions in which the reactant B also reacts to give reactant A. So we write it by another arrow pointing in the opposite direction. So what is a reversible reaction? Let us define it. A reaction in which the product also reacts to give back the reactant is called as a reversible reaction. Basically, every reaction can be made irreversible, but under different condition of temperature and pressure. If you have changed the temperature condition of temperature pressure of this B, it will change into A, but that is not a reversible reaction. Reversible reaction means it has to be reversible under the same condition of temperature and pressure, means in the same flask where the reaction is taking place. A should give B and B should give A. This is called as reversible reaction. A reversible reaction is the one where the reactant A gives B and product B also reacts to give A. Yeah. Now, fourth, equilibrium. What is equilibrium? This is very important. Let us consider a reversible chemical reaction A giving B. So if a student forgets to mention reversible, he is wrong, because equilibrium is only in reversible reaction. He has to mention the word reversible. Now, reaction A giving B, where A is the reactant, B is the product. Now see, this axis is rate of reaction and this is time. Initially, the rate of forward reaction, see, reversible reaction is having two reactions, forward reaction and backward reaction. Initially, the rate of forward reaction will be very high. Why? Because the rate of forward reaction is directly proportional to the concentration of the reactant. And reactant, suppose you have taken 10 moles. So it is very high. After some time, this 10 moles will become 9 moles. So according to law of mass action, rate will be directly proportional to 9. Then after some time, 8, 7. So you can see that the rate of forward reaction goes on decreasing. Then let us see what about the backward reaction. According to law of mass action, rate of backward reaction will be directly proportional to its reactant, which is B over here. Initially there was no B, so the rate is 0. As the reaction proceeds, this becomes 1, 2, 3, 4. So rate will go on increasing of the backward reaction. This is the rate of forward reaction. This is the rate of backward reaction. And a stage will come when the rate of forward reaction is equal to the rate of backward reaction. This is called as chemical equilibrium, where the rate of forward reaction is equal to the rate of backward reaction is called as chemical equilibrium. And at that moment, at that time, it will look like the reaction has stopped. But it has not stopped. It is moving with the same speed in the opposite direction. Hence, chemical equilibrium is dynamic in nature. Dynamic, not static. The reaction is moving with the same speed in the opposite direction. Hence, it is dynamic in nature. So, what is chemical equilibrium? Where the rate of the forward reaction is equal to the rate of the backward reaction. Now, we'll start with the fifth one. What is the equilibrium constant? K. Remember that the rate constant was small k. Equilibrium constant is K. So, there is a derivation for it. Let us consider a reversible chemical reaction A plus B giving C plus D. Again I say, while deriving equilibrium constant, if you forget the word reversible, you are wrong, absolutely wrong. And while writing the reaction, if you don't write this reverse arrow, it is wrong. You will have to write the reverse arrow. Anyhow, we start with the derivation. A, B are the reactants, C and D are the. Apply the law of mass action for the forward reaction. Forward reaction, first point. Apply the law of mass action for the forward reaction. What is that? Rate of the forward reaction is directly proportional to the concentration of the reactant, which in this case are 2. So it is product of the concentration of the reactant. Therefore, RF will be equal to KF, concentration of A into concentration of B. What is KF? KF is rate constant of the forward reaction. RF is rate of the forward reaction. KF is the rate constant of the forward reaction. First point over. Second, now look here. For the backward reaction, let us apply what is rate. What is the rate of the backward reaction? So for backward reaction, the reactants are not A and B, the C and D. The reactants have changed, so there are 2 reactions taking place. So RB is equal to KB into C and D concentration. What is KB? Rate constant of the backward reaction. Now nobody can question me, sir, you are saying that this is also constant, this is also constant, so both should be equal. No, both is not equal because both the reactions are not the same. Forward reaction is different than the backward reaction. So KRB is rate of the backward reaction, KB is the rate constant of the backward reaction. Now what is equilibrium? Equilibrium is a state where rate of forward reaction is equal to the rate of backward, not the rate constant. Equilibrium is the position. So see, at equilibrium, rate of forward reaction is equal to the rate of backward reaction. So we will have RF is equal to, see here, KF into concentration of A into concentration of B is equal to KB into concentration of C into concentration of D. Therefore, KF upon KB is equal to concentration of C into concentration of D upon concentration of A into concentration of B. Look here, it is the ratio of two constant, rate constant of the forward reaction upon rate constant of the backward reaction. Ratio of two constant is another constant K called as equilibrium constant. So you have two ways of defining what is equilibrium constant. Let us define. Equilibrium constant is defined as ratio of rate constant of the forward reaction to the rate constant of the backward reaction, or it is the ratio of concentration of the product upon concentration of the reactant. Be careful, it is forward upon backward, it is backward upon forward, then it is concentration. Again I repeat, equilibrium constant is equal to the ratio of rate constant of the forward reaction to the rate constant of the backward reaction, or it is equal to the ratio of concentration of the product upon concentration of the reactant. If you want to use correct English, you can say it is defined as the ratio of product of concentration of the product to the product of concentration of the reactant. This is called as equilibrium constant.